Welcome to the IT Fundamentals Training Series. This is Chapter 1, Episode 10 already. 10 different episodes. I'm your host, Mark Haupt. And welcome to today, which is going to be a complex conversation about processors. You thought we already talked about them? Well, wait until you get through this episode. Let's roll. Welcome to IT Fundamentals Training Series, Chapter 1, Verse 9, Verse 10, actually. Sorry, it's not really verse. You just kind of feel like it's a long song that keeps on going. It's actually Chapter 1, Episode 10, and we are progressing through. If you're following along page by page, we're on page 23, and we are going to work through to page 26 today. So it is going to be a little bit of a longer episode, and if you have never taken notes, today's the day to take notes. Perhaps even listen through it once or twice in the car and then go back and take notes, because there's a lot of important stuff today that we need to talk about that is actually going to end up on the test. And there's also going to be a lot of repeated stuff, which means one of two things. Either you could take the mindset that repeated stuff is boring and you're going to skip over it, and then all of a sudden you're going to find out you missed a whole bunch of things that you need to know for the test. Or you can look at it and realize that if it's repeated, it's important. And a lot of you that know me personally have heard that before, because I got it from an old preacher friend of mine, about Bible verses. When things are repeated inside of that type of scripture, then it must be important, something to pay attention to. And that's what we need to do here today, is pay attention to what's going on. So starting out on page 22, just at the very bottom, it identifies processors, and it talks about something we've already known. And I've told you over and over again that part of what the basic thing, the main thing that you need to get from a lot of these conversations are what the definitions of acronyms are. And so it talks about the role of the central processing unit. Now, I'm going to take a little bit of a tangent here. Notice that it says in here that the processor is like the brain, but and I'm going to quote here, but the analogy isn't perfect because the processor isn't capable of thinking independently. Well, this book, scary enough, is only a couple of years old. In fact, if you go back and you look at the trademark or the copyright on it, this is a 2018 book. And it's legitimate, especially for IT Fundamentals Plus. But that statement in there is now patently false. Now, for the test, you have to remember that that's the answer. If that comes up on the tests, what is a CPU? Is a central processing unit, and it's kind of like the brain, but the analogy might not be perfect. Well, in today's world, it actually is perfect because of something we call machine learning and artificial intelligence. And I'm not going to go down the path anymore, down that divergent path than we've just gone, but just to understand that if you're reading that and you're questioning with all the AI and the ML stuff that's being talked about today, is that a true statement? Well, when the book was written, it was very true. And that was only a few years ago, which my point here is to show not the fact that the book and things change, in accordance in the space of the book here, but that's how fast technology changes. In fact, this whole AI ML thing has really taken off in the last 6 to 12 months. And today is the roughly the middle of July of 2023. So a year ago from previous, we were barely talking about AI from a true artificial intelligence capability, and here we are now living in AI with Chat GPT and things like that. But anyway, I digress. Okay, back on schedule here. So page 22, central processing unit. You need to know the definition, the acronym of that. Chapter 20 or page 23. Here's something of interest that you definitely need to pick up that's new, and that processors are small silicon chips. There's a whole bunch of small silicon chips that are on these processors, and actually there's not only that, but there's millions of transistors that are built into these Intel and AMD chips. And that's something else that you need to know for the test, is that there are two main producers of these chips, these CPUs, and one is Intel and the other one is AMD. Okay, so that's an important piece that is new, that you need to keep in mind. All right, so moving on through, It does repeat a lot of the things we talked about. You can go back into a previous episode and learn about the pin grid array and the land grid array, the LGA. I'm not going to go back over those. But make sure that you take a look at that. And then right under figure 1.15, which is an AMD Athlon chip, is talking about the heat sinks. Again, we talked about that in a previous episode. I'm not going to talk about it again here, but I am going to talk about CPU characteristics, architecture, speed, cache, and some CPU functionality. All right, so let's talk about CPU characteristics. First of all, it does accurately state that the most important characteristic of a processor is, does it fit into your motherboard? Now, that may be slightly misleading in this sense that it is the most important piece, because you don't want to jam a processor, and you don't want to use the wrong processor that's associated with your motherboard. So when they're talking about does it fit into your motherboard, if fit isn't just physical, although it is physical, isn't just physical, it is also, is the motherboard built for that type of processor? Are the pins lined up properly, and so on and so forth? But beyond that, it talks about the fact that there's literally dozens of processors out there, and that's 100% true. And sometimes it gets a little difficult on trying to decide which one you want to buy. So then the book talks about on page 24 about architecture. Now, there's a couple of things I want you to get out of this. First of all, I want you to understand the difference between the 32-bit and 64-bit, and then the ARM processors. So let's talk about the 32 and the 64-bit first, and let's understand what those are. And then we'll talk about the ARM processors. So the 32 and 64-bit is not only written as 32-bit or 32-bit or 64-bit, 64-bit, but you'll also more frequently see it as X32 or X64. In fact, I don't even know that they sell X60 or X32 computers out there now. They do have software that's X32, but probably not computers. Now, what that simply means, that 64 or 32 simply means, is how much of a pathway, or how much of a bus, how many different lanes, if you're thinking about this as a superhighway, as a bus, as a superhighway, how many lanes go from the CPU to the RAM, the volatile memory? Okay, because remember, the CPU is only, all it's basically do is computing math. All right. And then what it does is it transfers that to the RAM so that the computer can easily access the results of that and present that to you on the screen, or however it needs to present that. So 32-bit and 64-bit is how many paths exist between the CPU and the RAM. Now, you can get 32 and 64-bit software, which, if it's a 32-bit software, it will limit itself. Even if there's 64 physical paths, it will limit itself to the 32. And so what are we dealing with when we're dealing with 32 and 64-bit software? Is your 64-bit software is actually going to run more, it's going to run faster, because what will happen is the CPU will process it, it will transmit it at a higher rate, which results in it showing up on your screen, or whatever action is necessary after the processing exists. It will transmit it, and it will show up faster if it's at 64-bit than it would be at 32-bit. But there is legitimately software out there that just doesn't need more than 32 bits, so you may not actually see it running slower. It may happen. All right, so that's an important piece that you need to look at there. Now, talking about these ARMs, or the advanced RISC machine type of processors out there. The part for the test, I want you to read this entire thing. Okay? It's very important you read this entire piece here on architecture. Don't skip over it. Make sure you understand it. This is probably, if I don't get questions on this section here, I'm going to be absolutely surprised, because I'd love to go deeper on that. But particular with your questions, but read through this and understand that the RISC processors simply, they are processors. They simply process the math differently than a 32 or X32 or X64 processor would. The way I liken this one is, you can do math regular way, long division, for example. You can do it the old-fashioned way, where or you can even do math 1 + 1 = 2 the old-fashioned way. And then there's this whole new thing that some of you actually did in school, or perhaps your kids are going through in school, that I just don't get, and it's called Common Core, but somehow you get to the same result. that you would if you just did it the old-fashioned way, like I did whenever I was going to school, and I still do. Well, that's basic difference between ARM and 32 and 64. 32 and 64 do it the old-fashioned way, and ARM with these RISC processors does it the Common Core way. You can think of it that way. So the RISC processors, RISC stands for Reduced Instruction Set Computing. There's an argument to be made that the RISC processors are not as fast and not as complex. But here's the thing: the RISC processors do have their place in computing, and in fact, you probably have one of them. You may be using a RISC processor while you're listening to this here, because the key piece here is about center of page 24. You'll see that there are two bullet points here. I want you to read those very carefully. In fact, I'm going to read them to you. The ARM processors are made in both 32 and 64-bit versions, so you'll find them in workstation servers, albeit not very often. That's the thing, is you hardly ever find the ARM processors in a traditional computer, tower, desktop, laptop, server type of environment. And that is because the second bullet point, they can be made smaller and produce less heat, which means they're used in things like your mobile devices, like your phones, your iPhones and your Androids, your iPads and things along those lines. So the ARM processors, and again, I'm quoting right here, ARM processors produce less heat. ARM processors are generally used in devices that are tablet sized and smaller, like mobile phones. Roughly 90% of all small devices use these ARM chips. Now, why are we doing that? Because typically the graphics and the functions that occur on these mobile devices are not as complex as what you would find on a desktop. You typically, now this is changing, and again, remember the age of this book, this is changing, where you can now start doing a lot of graphic design and things like that on these tablets and mobile devices. But typically you're not going to be doing that if you are a graphic designer or someone along those lines. So that's where the ARM processors are important. And then it goes on to say that another term you'll hear in terms of architecture is the number of cores a processor will have. So if you're going to buy a new computer at Best Buy, for example, you're going to see an Intel whatever, i7 with 6 cores or 8 cores. Basically what that means is that there are when it says 8 cores, for example, there's actually 8 small CPUs, either physically or virtually, within the one CPU case that's been plugged into your computer. And so what this does, by isolating them either physically or virtually, most are physical, is it allows processing to occur independently. And going back to that 32 or 64-bit scenario with the bus coming out, you could actually have, if you've got 8 cores, you could do the 8 times 64, and you have that many bus connections going to your RAM, and therefore it produces the images and such faster on the computer. So this is a way that Intel and AMD have gotten around creating more and more powerful chips. What they've done is they created more and more smaller chips that they've packed inside of the chip case and just simply multiplied them in those spaces. All right, the next thing that we need to look at, and I told you this is going to be a long one where you have to go back and take some notes and do some reading, but we're going over it. So the next thing we need to look at is speed. And everything is generated in speed in hertz that are electrical cycles. So if you take a look at that section there, you're looking at hertz. So you're looking at megahertz and gigahertz is what we're talking about now. And most of our computers are running in the gigahertz. In fact, all of our computers, I think, are running in the gigahertz cycle. And again, these types of things are actually throttled back a little bit on the ARM devices. So the chips that are inside your iPads and iPhones could actually process more than what they are currently processing as a result of that. So the higher the number of gigahertz, the faster that it's going to run electrical cycles through that. All right, on page 25, it talks about cache. Now, cache is simply this, and this is probably the only thing, well, maybe two things you need to know about cache. But cache is a reserve source. It's exactly what its name means. It's a quick form of memory And actually, I'll just quote it here. It says, cache is a quick form of memory that greatly speeds up the performance of your computer. Typically, cache is, again, it's volatile memory, and typically it's held on your hard drive. So there will be a segment of your solid state drive or your spinning disk hard drive that's carved out to act as additional memory, so the CPU can shovel things off to that. And the reason for that is because a lot of times, even with a 64 gigabit memory, or even 128 gigabit memory, there's only so much that your onboard memory of your computer can hold. And if you're doing high graphics or high video type of content, it's going to need to store it in another place, or it overwrites what's inside of your memory. When it overwrites your inside of your memory, it can't be retrieved, which means it has to go to the CPU and be reprocessed and then replaced back onto the volatile memory. You see how that can slow things down a little bit. So in order to speed it up, in order to retrieve it quickly, the system needs to retrieve it from a cache or another form of volatile memory. And that's simply it's simply it. That's what it is. Now, for the test, I encourage you to read these items here about L1 cache and L2 and L3 cache, just so you understand what those are. Probably creating some sort of flashcards on that. So your L1 cache, you're going to want to know that it's a 64 KB kilobits. L2 is 256 kilobits, and L3 is a 4 meg to 12 meg type of scenario. So where your RAM could be, actually it says 4 gig to 64 gig, but I've got 128 gig type of machine right now. So that's important for you to understand, that the difference between the L1, L2, L3 and RAM. And know again that from volatile memory perspective, your RAM is your first and primary. The cache is only a backup. And frequently what it stores in cache are things that are frequently used but small in size. And it will actually, the computer will actually determine that for you. All right, so the last thing we're going to talk about here at the bottom of page 25 is the CPU functionality. I really don't need to talk too much about that, because I think we all get what the CPU functionality is. But it has one function, and that is math. It doesn't matter if the CPU is the primary CPU on the motherboard. It's a secondary CPU on a graphics card, or what they call a GPU, graphics processing unit. By the way, a GPU is nothing more than a CPU that's specific to the graphic card. Doesn't matter what you're looking at here. The GPU, the CPU, that processing unit is processing math. It's a big honking calculator is what it is. And it can do math faster than any person, any way, shape, or form can do it. Now, do keep in mind that the instruction set is based off of ones and zeros. So it's based off of binary, and that's what it understands. And so we could get into ones and zeros and binary counting and all that kind of stuff, but that's not necessary for ITF Plus. And frankly, that just gets confusing. But there are people, believe it or not, it's like a foreign language. There are people out there that can read binary. Not I. I've seen a couple of license plates that are binary type of functions. All right, so that really is a lot of information. I want you to read over that, probably take a couple of notes, ask me questions on these types of things. This is probably the toughest thing that we've had come up so far, so you can start seeing that we're starting to get a little bit deeper into these things and understand. Now, Ed, before we take a quick break, this is episode 10. It's the end of the week. There is an exercise in here, exercise 1.1. I want you to go over this exercise. There looks like there's eight questions in 1.1, and it's really a little bit of a binary exercise, but keep in mind that this is only for fun. You do not need to know binary or hex or anything like that for the test. So if you find this confusing to you, don't get frustrated. If you find that it's not fun, put it aside. It's not something that you absolutely must know. Just know that binaries are ones and zeros, and 1 0 is simply on or off. 1 is an on. A 0 is an off, and a string of those put together is an instruction set. That's really all you need to know about binary for this exam. You don't need to know how to convert it all. All right. Once again, been a great session. Hopefully it has been for you as well. It's been a long one. I understand that. Hopefully we won't go this long on others. But again, looking forward to your questions. MHOUPT at commonsensesecurity.net. Love to have your questions. And look, if you're on episode 10 and you haven't subscribed and clicked the little bell on YouTube or put in the notifications on the other apps like iTunes and whatnot to let you know when the next episode's coming up. Now's the time to do that. Go in there, as long as you're not driving, of course, but go in there and subscribe. Make sure that you are notified of the next episode that comes in, because as you can see, these build on one on top of the other, and would love to have you in sequence so you don't miss something that was important in the previous pages. All right, looking forward to episode 11. We're going to talk about memory a little bit in episode 11, and then we'll go from there. Thanks much.